All right, in this video, we're going to talk about Section 5E, Correlation and Causality. That will wrap up Chapter 5. Here in Section 5E, we will discuss how statistics can be used to search for correlations that might suggest a cause and effect relationship. Then we'll explore a more difficult task of establishing causality. Okay, let's talk about what a correlation is. Correlation exists between two variables when higher values of one variable consistently go with higher values of another variable, or when higher values of one variable consistently go with lower values of another variable. Okay? That's basically what a correlation is between two variables. And a few examples of correlations would be that there is a correlation between the variables height and weight for people. That is, taller people tend to weigh more than shorter people. Okay. Also, there's a correlation between the variables demand for apples and price of apples. That is, demand tends to decrease as the price increase. Also, there's a correlation between practice time and skill among piano players. What that means here is those who practice more tend to be more skilled. Okay. And one way of illustrating if there is a correlation between one variable and another variable would be to use a scatter plot. Now, a scatter plot by definition is a graph in which each point represents the values of two variables. Okay? So this is an illustration of what a scatter plot looks like. On the horizontal axis is the production cost. The vertical axis represents the U.S. gross receipts. Okay? And this is dealing with biggest budget movies through 2016. Okay. Now, let's look at the relationships between two data variables, okay, and the types of correlation that they may have. One, you might not have any correlation at all. That means there is no apparent relationship between the two variables. So if you were to look at a graph and you see points that are just scattered everywhere on the in the plane, let's say we have this, and let's say that the points are just scattered everywhere. Like this. If they're scattered everywhere like that, that means there's no correlation, because we can't determine what type of correlation we're going to have. On the other hand, you may have a positive correlation. Now, that's where both variables tend to increase or decrease together. Okay? A negative correlation is this. One variable may increase while the other variable decrease. And I can illustrate that to you as well. A positive correlation would be where these points are going in the upward direction, like this. But for a negative correlation, as one variable increases, then the values decrease. And the strength of a correlation is this. The more closely two variables follow the general trend, the stronger the correlation. In a perfect correlation, all the data points will lie on a straight line. Okay? So if your points lie on a straight line, you'll have a perfect correlation. Now here's an illustration of what a positive correlation is and what it looks like, as you can see in this particular graph here. The weight in carats of a diamond, and then the price in dollars. As the weight of the carat increase, the price of the diamond would increase. And here you can see that the scatter diagram shows that higher diamond weight generally goes with the higher price. And a negative correlation will look something like this. As you can see, as our x values increase, these values here, the points will be going in the downward direction. That means in this case here, we're dealing with life expectancy and infant deaths. It shows that higher life expectancy generally goes with lower infant mortality. All right, now let's look at some examples of this here, dealing with correlation. Here we want to consider the scatter plot to the right and state whether the diagram shows a positive correlation, a negative correlation, or no correlation. If there is a positive or negative correlation, is it strong or weak? And then part B, you're going to summarize any conclusions that can be drawn from the diagram. So here we got this diagram that deals with model cars in 2014. And by looking at this, we can see that these points are going in the downward direction as we let the weight of the cars increase. That means the city gas mileage will decrease. So there is a negative correlation. And in this case, now since it's going in the downward direction, this will have to be a strong negative correlation. Okay. And based on this answer right here, part B, select the correct answer below. Here, heavier cars, as the weight of the cars increase and the city gas mileage goes down. Okay, so it would be this answer choice here. Heavier cars generally get lower gas mileage. Okay. Now let's look at this example here. Again, I'm going to state whether the diagram shows a positive correlation, a negative correlation, or no correlation. If there is a positive or negative correlation, is it strong or weak? Summarize any conclusions that can be drawn from the diagram. Okay. I'm looking at this and I'm seeing that most of these points are going in the upward direction here. But it's not what we call a strong correlation here. It's more like a weak positive correlation. So I'm choosing that there is a weak positive correlation. Okay? And select the correct answer below. Summarize any conclusions that can be drawn from that diagram. And in this case, if you have a higher adjusted gross income, or AGI, that might imply a slightly higher charitable giving as a percentage of AGI. It's just slightly higher because it's a weak correlation. Okay. All right, next we'll look at possible explanations for a correlation. Possible explanations means that the correlation may be a coincidence, or both variables might directly influence by some common underlying cause, might be directly influenced by some underlying cause, or one of the correlated variables may actually be a cause of the other. Note that even in this case, it may be only one of several causes. Okay, those are possible explanations for a correlation. Might be a coincidence that the correlation exists. Both variables might be directly influenced by some common underlying cause, or one of the correlated variables might actually be a cause of the other. And here it may be only one of several cases or several causes. Okay. Let's look at this example. For the following pair of variables, state the units that might be used to measure each variable. Then state whether you believe that they are correlated. And if you believe that they are correlated, state whether the correlation is positive or negative and explain your reasoning. In this case here, weight and how frequently a person attends country concerts. Okay, so to measure weight, the unit might be used. And here's the choices that they're going to give you in the drop-down menu. Either feet per second, liters, degrees of Fahrenheit, or pounds. So if you're measuring weight of somebody, it has to be in pounds. So obviously you have to select pounds. To measure the frequency a person attends country concerts, the unit, and it'll be one of these, must be used. Either the number of attendances, degrees of Fahrenheit, cubic feet, or pounds. It would have to be the number of attendances. Because, of course, a person attends a concert, you have to look at the number of attendances that person would attend a concert. Now, what correlation, if any, is there between the weight of the individual and the number of concert attendances? There is no correlation between those two. We can't make a correlation between those two. A person's weight wouldn't necessarily have anything to do with how frequent a person attends country concerts. So those variables would not be correlated. Okay. All right, here's another example. Okay, in this case here, you're going to state the units that might be used to measure each variable, then state whether you believe that the two variables are correlated, and if so, state whether the correlation is positive or negative, and explain. Okay, the age of a person and time spent on social networking sites. Well, to measure age, which of these units do we need to use? Well, based on that, we have to look at the years since a person was born. Okay, they'll give you a choice, and you'll pick the one that makes sense for that particular situation. Because for age, it's going to be years. So it has to be years since a person was born. And then to measure time, we could use, in this case here, the time spent on social networking sites. We have to use the hours. So it's just the time. So it's going to be hours spent on social networking sites. And then what will be the correlation, if any, is there between the person's age and time spent on social networking sites? In this case, there is what we call a negative correlation. Okay. Because the time will increase as age decreases. The younger you are, the more time you'll spend on the networking site. Okay, next example of this. Okay, let's say average property tax in a school district and average number of computers in each school. Okay. Here we're going to state the units that might be used to measure each variable, and then state whether we believe that the two variables are correlated. If so, whether it's positive or negative, and explain. Okay, if we're going to measure average property tax, one of these units will have to be used. And taxes, of course, is going to be in dollars, so we'll use the unit of dollars. And to measure the average number of computers in each school, then one of these will have to be used. Average number of computers will have to be, obviously, the number of computers from this choice. Okay? And then next would be, what will be the correlation, if any, is there between those two variables? Well, we know the average property tax in a school is not going to decrease. It will have to be answer B. That there is a positive correlation between the average number of computers in each school tends to increase when average property tax in a school district increase. Okay? All right, now, next we'll look at some guidelines for establishing causality. Now, there are 6 guidelines that we need to look at. Number 1, you want to look for situations in which the effect is correlated with the suspected cause even while other factors vary. Okay. And then number 2, among groups that differ only in the presence or absence of the suspected cause, check that the effect is similarly present or absent. And then number 3, you want to look for evidence that larger amounts of the suspected cause produce larger amounts of the effect. Okay, that was something that we looked at in example 5, dealing with the average number of computers in a school district. It tends to increase when the average property tax in that school district increase. So those are larger amount of the suspected cause producing larger amounts of the effect. And then number 4, if the effect might be produced by other potential causes besides the suspected cause, make sure that the effect still remains after accounting for these other potential causes. Then number 5, if possible, test the suspected cause with an experiment. If the experiment cannot be performed with humans for ethical reasons, consider doing the experiment with animals, cell cultures, or computer models. And then finally, try to determine the physical mechanism by which the suspected cause produces the effect. Okay. So those are just some guidelines for establishing causality. Okay. All right, we'll look at this example here. The following table gives the average hours of traditional network and cable television watched per week in 5 age categories. Find for the age categories, use the data point 6, 15, 21, 40, and 65. Complete parts A through D, or through C. They're only A through C in this particular example. Okay, so here is the table that they give us. Now, I'm going to show you how to do this on the graphing calculator, mainly the TI-83 or the 84. Okay, for 2 to 11, we're going to use the number 6 as a data point. For 12 to 17, we're going to use the number 15. For 18 to 24, we're going to use the data point 21. And then 25 to 54, we're going to use 40. And then anything greater than 54, we're going to use 65. Those are going to be our data points here, and which will be to each of the weekly TV hours here that's given. We're going to show you how to do this on a graphing calculator. And I will have a handout on Canvas that shows you how to do this step by step. Okay, so if I clear this out. Now the way we're going to do that is, on the calculator there is a button that says STAT, the stat button. You're going to press that. We're putting in brand new data values here. So under the edit menu, we're going to select number 1 for edit. Now if you have anything in L1 like I have here, we want to clear those data values out. And we're going to do that by using the up arrow key to highlight L1. Then you're going to press the button that says clear, and then the button at the bottom that says enter. That will clear L1 out completely. Okay. In L1 on the left hand side, I'm going to type in these data points. The 6, type 6 and then press enter. Then 15, press enter. 21, press enter. 40, press enter. 65, press enter. Then I'm going to use my right arrow key to go to L2. And then I'm going to enter these data values that's under weekly TV hours. Here is 22.9. You'll type that in, 22.9, enter. Then 14.7, and then enter. Then 17.5, enter. Then 31, enter. 47, and enter. Now you want to make sure that you have the same number of data values in L1 as you do in L2, because these two have to correlate to each other. The 6 correlates to 22.9, 15 correlates to 14.7, 21 correlates to 17.5, 40 goes to 30.1, and 65 goes to 47. Now to create the scatter plot, here's what we're going to do here. I'm going to press the button that says second, and then press this button that says Y equal to at the very top. Okay? You'll get a menu that says stat plots. Now in my case, I'm going to select number 1 for stat plot. Well, for that. Now, mine's is off. For me to turn it on, I have to have that cursor blinking on the word on. And then I'm going to press enter at the bottom. That will turn the stat plot on. Now under type, it is a scatter plot, so already this first icon that's highlighted, I'm going to leave that there because that represents the scatter plot. So I'm going to leave that on, or you can put the cursor over it and then press enter because that's what you want. Your X list will be L1, and your Y list should say L2. And the mark can be anything you want, any one of these three. I'm going to leave the first one highlighted. Okay? And after that, I'm going to do second and graph. Sorry. Go back. go to Stat. Okay. I need to set the window for this one. So here, press the window key at the very top. These data values are from 6 to 65. So I'm going to let X min, I'm going to start at 0. And then my X max, let's say 70. The X scale, since let's do a scale of 10. Let's do increments of 10 here, in this case. And then the Y max, let's see here. This goes from 22.9 all the way up to, well, actually 14.7 all the way up to 47. So I'm going to start at 0 for the Y min. Y max, I think the highest is 47. Let's do 50. And then the Y scale, I'm going to do 10 as well. Don't worry about the X resolution. Don't worry about that. Press enter. Press the graph button up here. And that's what the graph will look like. And you'll have to choose which one of these will fit the one that you have on your screen. Based on that, I'm going to say graph B, because that looks somewhat like this one. Okay. You might be able to use process of elimination on this if you can. Okay. Now, part B, state whether the two variables appear to be correlated. And if so, state whether the correlation is positive, negative, strong, or weak. In this case right here, looks to me like this graph is going in the positive direction, going upward. That would be a strong positive correlation. So I'm going to choose this one. Because if you look at it, okay, that slope that we use, the height of it going in the upward direction, that's real steep. So it's a strong positive correlation. Okay, and suggest a reason for the correlation or lack of correlation. And in this case here, when we get older, we have more free time and can watch more TV. So the older a person gets, the more time that they will have to watch TV or free time. Okay. All right. The last thing we'll talk about is just this. This deals with confidence in causality. Okay. A possible cause could mean that we've discovered the correlation but cannot yet determine whether the correlation implies causality. In the legal system, possible cause, such as thinking that a particular suspect possibly caused a particular crime, is often the reason for starting an investigation. Okay? Now, there is something that you do need to know. That correlation will not imply causality. Correlation does not imply causality, meaning that one cannot be the cause of the other. Like, let's say smoking causes lung cancer. That's not always the case. So we can't we can't say that smoking will cause lung cancer, because there might be other things that might cause lung cancer. Probable cause is this. We have a good reason to suspect that the correlation involves cause, perhaps because some of the guidelines for establishing causality are satisfied. In the legal system, probable cause is a general standard for getting a judge to grant a warrant for a search or wiretap. Okay? And when police officers search your car, they do it because they have probable cause to believe that you might have, for example, drugs or weapons in the car. Because they have what they call probable cause to do it. Cause beyond reasonable doubt means we found a physical model that is so successful in explaining how one thing causes another that it seems unreasonable to doubt the causality. In the legal system, cause beyond reasonable doubt is the usual standard for conviction. It generally demands that the prosecution show how and why, essentially the physical model, the suspect committed the crime. And note that beyond reasonable doubt does not mean beyond all doubt. Okay? All they need is just a reasonable doubt to have what they call cause beyond a reasonable doubt to convict that individual. Okay? All right, so this will conclude this particular video on correlation and causality. And I do want to wish you the best on the homework, and do feel free to contact me if you have any questions about this.